Hi, today we're working on a lab where we are going to see water freeze, and we're going to watch it happen very quickly. So first you want to get together some things for your experiment: paper towel, metal can, salt, and some ice cubes. Your metal can, be careful of any sharp edges on the top, and the first thing you want to do is make sure it's clean and then very dried off. Then you're going to add 3 tablespoons of salt. Any kind of salt works: kosher, cheap salt, rock salt, whatever you have around. So 3 tablespoons of salt go into that can. You don't have to measure exactly here. This is a more qualitative lab than quantitative, so we're just observing and not so much measuring carefully. Then make a little ice cube disaster. Put a layer of ice in, fill it up maybe about halfway or so. Now you're going to add 3 more tablespoons of salt, give or take, or 3 more teaspoons, I guess. Kind of scatter it around a bit in there if you can. The reason we're adding the salt is when you add salt to water, it lowers the freezing point. And so we want to get something in our kitchen here that has a temperature that's lower than 0 degrees. We added more ice. We're going to add more salt here. So by adding the salt, we're going to get maybe to like -1 or -2 degrees. And that means that we can take our water and actually get it to freeze on our can eventually, because the water needs to be below 0 degrees to all stay frozen. So we're making a super cold collection of ice and salt here. This is time-lapsed a bit. You can see over time, first the water condenses on the cold can, and then eventually the water starts to freeze. That's kind of that frost at the bottom. So over time, more and more. Feel free to let this sit for like half an hour. So you basically made snow in your kitchen. You took the moisture out of the air, and it solidified on the very cold can. First it condensed, turned into water, and then it froze and turned into ice. Next up is an animation. So what we're looking at here is an animation that shows us water molecules, that's the red oxygen and the white hydrogens, that are in the gas phase. They're at a very high temperature. And so in the gas phase, we see that those molecules are moving very quickly. They're filling the entire container. In comparison to what you're seeing in this lab, this would be like water vapor that's present in the air around us. So as I cool this, we're going to put some ice down here at the bottom, and you can see as that ice is there, watch, this temperature is going to decrease, and this would be like the ice that's inside of the metal can in this lab experiment. So watch what's happening to the water molecules as they start to be near the cold bottom of the can. Notice that their speed is slowing down. They are hanging out closer to the cold bottom here, and what we're seeing here now is a liquid where there's not a lot of organization in the molecules, but they are staying close together like a puddle of water at the bottom of the can. And as I continue to cool it, notice what happens to their speed. It continues to decrease. And as I cool it even more, they actually spread out a little bit from each other. We're at a very cold temperature now. And you can even see, so they're still vibrating a bit. You can see there's some hexagons in here and there. And when water molecules freeze, they form these hexagon shapes. And so if this is my cold surface here, first we saw that the water condensed and formed a liquid, and now the water has gotten even colder and it's frozen and formed a solid.